My name is Ben Catton. I'm with the Montana Environmental Information Center. I'm a policy associate and was MEIC's kind of point person during our last legislative session in 2025, working on plastics, PFAS, and pesticides, sort of all of these chemicals of concern, synthetic chemicals of concern in our environment. Very lucky that we have our three experts gathered here today to give us this kind of overview of what are PFAS. We have Dr. Jamie DeWitt, who some of you may recognize if you watched the PBS Impact documentary. She was one of the speakers on there. She's a nationally recognized environmental toxicologist known for her groundbreaking research on how forever chemicals like PFAS alter the immune and nervous system. We have Dr. Kimberly Garrett of CUNY. She's an environmental health scientist whose research focuses on chemical pollution, particularly PFAS, using a mix of toxicology, spatial analysis, and public health frameworks. And we have Avonna Stark of Clean Water Action Minnesota. She's the state director, and she notably led a coalition to pass Amara's Law in Minnesota, one of the most comprehensive PFAS regulations in the world. So I want to say thanks very much to all three of them for being here. Very generous of them to share their expertise and their time with us. Just to give you a little preview of where we're heading, we want to contextualize the threat of this contamination in Montana, educate and raise awareness about the seriousness of this issue and the need for action. Our experts will help us understand what are PFAS, where do they come from, what do they do to us, why is this topic important at this moment, how might contamination change Montana's culture, economy, or access to clean drinking water? We want to preview some actions upcoming that you can raise your voice and insist to decision makers that they take action on this really important issue. If you share your email address with us in the chat or send it to us, we will send follow-up information in an email, including the slides, a recording of this webinar, and detailed instructions on how to engage about these upcoming comment opportunities. Just to briefly tell you what those are, on July 14th next week, the Montana Legislature's Environmental Quality Council will have a hearing on PFAS and fish tissue, where they will have the directors of three departments that oversee this issue, being the Department of Environmental Quality, Fish, Wildlife, and Parks, and the Department of Health and Human Services. And that'll be at 1 p.m. and we'll talk about real specifically how to get involved in that. But a really important opportunity to say, I want something done about this. I found this concerning. Also, July 20th, the week following, is a public comment deadline for two really important Environmental Protection Agency rules. And we'll share information on how to comment on those as well concerning PFAS and allowing polluters to pollute for longer or to pollute without consequence on four really important PFAS chemicals. And then, of course, the upcoming 2027 legislative session, it's going to be very important that people raise their voices with their decision makers and let them know that they want action on this issue. So we're very optimistic that this information coming to light will at least provide an opportunity for us to take action. So why does this matter right now? As mentioned, this PBS documentary has created a new spotlight on this issue. It's revealed that this contamination is already impacting our culture in Montana. We have a culture of fish consumption, of course. We love our fisheries. We love to fly fish and fish our lakes and streams and rivers and to consume that. And that's impacted now because we've been advised that it may not be safe, depending on where and how much and the size of the fish, et cetera. That's impacting our economy. That's a huge part of our recreational tourism economy. I want to say it's something like $1.4 billion a year that comes in through our fisheries. And so, of course, that's something that we want to maintain and we want it to be healthy. And it's really important to our health, our environmental health, and our human health. And if these chemicals are in the fish we're consuming, that means they're going to end up in us. It's also really important with regard to basics like our access to clean drinking water. This is a relatively recent notice that Kalispell is going to have to spend $18 million to replace some wells that were contaminated with PFAS and to create new water transmission in order to get that water, clean water, unimpacted from PFAS to people. So this is about safety, basic safety, and it's one of those situations where an ounce of prevention is worth a pound of cure. So to kick it off, we're going to have a PFAS 101. Very fortunate to have Dr. Jamie DeWitt deliver that to us.
Well, thank you very much, Ben, for that introduction.
Give me 1 second. I'm shuffling papers, but I want to give you a full introduction. Hold on.
That's
So
okay.
Dr. DeWitt is a director of Pacific Northwest Center for Translational Environmental Health Research and a professor of environmental and molecular toxicology at Oregon State University. Her laboratory research program explores effects of environmental contaminants on the immune system with a focus on the adaptive immune system and antibody responses. She's especially interested in emerging or understanding contaminants, including per and polyfluoroalkyl substances, and serves as a plaintiff's expert witness in cases concerning PFAS. She was featured in the recent PBS Impact episode titled Investigating Forever Chemicals in Fish that brought to light the extensive PFAS contamination in Montana fish populations. Thank you, Dr. DeWitt.
All right. Now, thank you for that introduction. And for those of you who have heard me speak before, some of this will probably be a repeat. But for those of you who have not heard me speak or are new to PFAS, hopefully this will give you a little bit of foundational knowledge. So if you pop over to the next slide. Ben already did note some of my declarations. I do speak a lot about PFAS. I serve as an expert witness in cases involving PFAS. I was on the US EPA PFAS Science Advisory Board, which is the board that reviewed the science behind the proposed maximum contaminant levels for 6 different PFAS. I also was a fellow concerning PFAS at the North Carolina Department of Environmental Quality not too long before I moved out here to the West Coast. Next slide, please. Well, what are PFAS? PFAS is an acronym for per and polyfluoroalkyl substances, and there are thousands to millions of PFAS in the class of synthetic chemicals that are known as PFAS. They have a specific definition. It's given by the Organization for Economic Cooperation and Development, and very simply put, they are a string of carbons, as you can see in the gray in the figure, where hydrogens that would normally be affixed to the carbon have been replaced with fluorines, as you can see in the bright green. There is a tail region that is known as a functional group and a head region that reflects the carbon chain. And this unique chemical structure gives PFAS some of the characteristics that make them useful in certain products and processes. Next slide. There, as I mentioned, are many different structures of PFAS. You may have heard of certain PFAS known as perfluorooctanoic acid or perfluorooctane sulfonic acid, PFOA and PFOS. These are currently regulated in drinking water by the US EPA. These are considered to be longer chain PFAS. These different structures can confer slight differences in terms of where they can go into our bodies and whether or not they get into our bodies or leave our bodies quickly or slowly. But I want to emphasize that all PFAS do share one or more characteristics that are concerning to toxicologists. Now, I did mention that there are many thousands of structures. At least one scientist in reviewing some of the structures of chemicals in a chemical structure database has asserted that there could be millions of individual PFAS. Now, I mentioned there's the OECD definition. It is possible that the definition of PFAS could be modified by different entities, and these modifications are usually done for management purposes, but I want you all to know that there is a singular chemical definition for PFAS that is accepted by the scientific community as an appropriate chemical definition for PFAS. And this may matter in some instances when management decisions are made to exclude certain chemicals that technically are chemically PFAS. Next slide. As I mentioned, PFAS have certain properties that make them useful in different processes and products. Some of these products you may have in your homes. The main chemical distinction of PFAS is that bond between Carbon and fluorine is extremely strong, which makes PFAS useful molecules because they're very durable and resistant to many different harsh conditions. Because of this chemical structure of PFAS, they're used in various industrial processes as starting materials or as surfactants or as processing aids for the creation of other products. You're probably most familiar with them because of their stain, grease, and water repellent properties. One of the items that you might have in your home is a nonstick pan. These are often coated with something known as polytetrafluoroethylene, which is a fluorinated polymer that gives that pan its nonstick coating. But as you can see here, and it looks like we had a little bit of translational issues in the slides from PowerPoint to Google Slides. So the medical devices aren't actually, triangles with exclamation points, but look at the words under the pictures. As you can see,
I
PFAS are
apologize,
used
Dr. DeWitt. I should have double checked that after adding them in here. That's on me,
in,
folks. Thank you.
it is what it is. And I think the words are fine. And I think people can understand that there may be many different items in their homes that could contain PFAS. They could either be fluoropolymers or some of the other agents. Some of them may be essential to that particular product. Some of them may not be essential. We can move on to the next slide. Now, PFAS are called forever chemicals colloquially by members of the press and some members of different communities. They're not actually forever, but as far as we know, they can last in the environment for decades to perhaps even centuries. And if you click forward, Ben, the PFAS will pop up on this list. Now, when I was in graduate school, I studied dioxins and polychlorinated biphenyls. And you can see here, polychlorinated biphenyls have a half-life of about 8 to 15 years in water. We think PFAS might last in the environment, as I said, for decades to centuries. Some scientists have asserted that they may even last in the environment on geologic timescales. So they're called forever chemicals in part because they persist in the environment. Once a PFAS goes into the environment, it usually stays a PFAS. There are PFAS known as precursor PFAS that can degrade, but when they degrade to stable end products that are PFAS. So even something as simple as trifluoroethylene, which is the simplest PFAS, is persistent in the environment. So next slide. Another reason that PFAS are referred to as forever chemicals is that many of them tend to last for a long time in the bodies of living organisms. So many PFAS can move from the environment into our bodies. That's bioaccumulation. Once they're in our bodies, they tend to stick to proteins. So they stay in the blood in proteins, and then they move into and out of different tissues or cells based on how well they like different types of proteins. So we think that how they interact with proteins influences how long they stay in the body and influences the types of tissues and cells that they interact with to produce adverse health outcomes. As you can see on the chart that's listed below the pictogram, PFAS can have a range of biological half-lives, with some being excreted from our bodies in only a few days, but some being excreted from our bodies after a few years. And I want to point out that that's the biological half-life. So that is 4 to 5 years for half of the amount taken in to get excreted. So you can see that if you have a continuation of exposure, there is the potential for PFAS to build up in your blood over time. And when PFAS build up in blood, that increases the likelihood that they're going to interact with molecules within your body to produce adverse health outcomes. Next slide. PFAS matter because they're almost everywhere scientists have looked. This is a slide from the Environmental Working Group that uses data from drinking water monitoring, and they've put together this map to highlight areas where PFAS have been definitively measured or detected in the environment. And if you click forward, Ben, a box will come up. So you can see that Montana doesn't appear to have many PFAS in it. I don't think that you should be cheering and saying, yay, we don't have any PFAS in the state. It's probably just that the state hasn't engaged in any widespread environmental monitoring for PFAS. If you have airports, if you have military bases, if you have construction and debris landfills, if you have wastewater treatment facilities, you likely have PFAS getting into the environment, including surface waters and groundwaters. So this map depicts states that have looked for and found PFAS. It does not depict states where no PFAS have been detected. It's just that those states that don't have PFAS haven't really looked for them. So this is just really the tip of the iceberg for many states. Next slide. PFAS also matter because they can be in many different parts of the environment. They can be in air, water, soil, wildlife, the food we eat. And because many of them can move from those environmental compartments into our bodies, they get into our bodies. We also know that PFAS can be passed from pregnant people to the babies that they're carrying through umbilical cord blood and through breast milk. This matters because we're all exposed and we all need these different environmental compartments to enjoy our lives. Next slide. And PFAS matter because once they get into our bodies, they have been reported to be linked to various diseases. And I mentioned that PFAS can interact with proteins. We think that drives disease risk. And if you look at this list of health outcomes, there are many different systems and cells in our bodies that can be affected when PFAS build up in our bodies. And these diseases range from endocrine disruption, with some of the evidence pointing to the impacts of PFAS on the thyroid gland. So hyper and hypothyroid, as well as thyroid cancers, have been linked to PFAS. Some studies of people have demonstrated that there's elevated cholesterol, and this has been observed in both adults and children. Liver damage has also been observed in various studies. This would be an increase in certain enzymes from the liver that indicate that the liver is being damaged. You might have these evaluated through a basic metabolic panel that you might have annually to keep abreast of your overall health. Different types of cancer have been linked to PFAS exposure. The ones with the strongest evidence are kidney cancer and testicular cancer. Developmental effects have been reported. The main type is an increased risk of being born at a low birth weight. And then the immune studies that have been done indicate that exposure to PFAS reduces responses to vaccines. I want to point out that these are all of the studies that have been mostly identified in epidemiological studies of people who work with PFAS or who live in areas of PFAS contamination. But most of these health effects also have been observed in experimental animal models given single PFAS. So we know that when we see these effects in humans and when we see them in experimental animals, our confidence is increased that the effect is actually real and is not just some sort of an artifact. Next slide, please. In 2022, the National Academies released a report on recommendations for healthcare providers for people living in PFAS impacted communities. This committee looked at the epidemiological evidence and based on the strength of that epidemiological evidence, made recommendations for healthcare providers about how they may wish to increase or elevate standards of care for patients at risk for elevated levels of PFAS in their blood. This is freely available online. If you just Google NASM Clinical Guidance PFAS, you'll be able to find the report and download it. It may be interesting to share with your healthcare provider if they don't know anything about PFAS, but this is designed to help people get ahead of diseases that they might be at increased risk for developing. Next slide. That's the end of what I have to present with you today. I just want to highlight 2 information sources. The PFAS Exchange is a really nice information source. It helps you to find out a little bit more about health effects and may help you to understand what your risks of exposure are. And then PFAS Central is the place to go if you really want some in-depth scientific information. It keeps the database updated with new literature that comes out on PFAS. There's my email there as well in case anybody has a specific question you'd like to ask me. Thanks again, Ben, for having me, and I'm happy to answer questions when we get to that point.
Wonderful. Thank you so much, Dr. DeWitt. And my apologies again for the distortion on your slides there. That's on me for the translation from PowerPoint to Google Slides. Next up, we have Dr. Kimberly Garrett of CUNY, and she is with the School of Public Health and Health Policy. She's an assistant professor and environmental health researcher working at the intersection of environmental toxicology, public health, and environmental justice. Her work situates chemical toxicology within built, natural, and social environments, Her recent work focuses on per and polyfluoroalkyl substances, PFAS, pollution, and spatial distribution of PFAS sources, along with the sociological impacts of contamination. Thank you very much, Dr. Garrett, for being here today.
Great, thank you for having me. And thank you, Dr. DeWitt, for a great background on PFAS and introducing specifically maps of PFAS. So I'm going to spend some time talking about maps and what we know about where PFAS is coming from. So when I was invited to this panel, I learned about the Montana situation with PFAS, and I'm thinking about, the discovery of PFAS within the state, in-state environmental media, and what that might mean for the impacts on Montanans, as well as what it means for kind of the history of PFAS use and distribution in the state, because that's how it gets into environmental media, is uses by different industries and different types of sites. And so in thinking about the discovery of PFAS in Montana, I wanted to know, what kind of sites are in Montana that PFAS might be coming from. And so to share that information with you, I'm going to first introduce some information on where PFAS come from. So all of this information is going to focus outside of drinking water. So that's why I've titled this Looking Upstream. I know there's a lot of information or a lot of concern about PFAS in drinking water. And where my research sits is a little bit farther upstream. So we're going to look at how PFAS get into the environment, what happens when they get there, and what that might tell us about where we'll find PFAS in the state. Oh, next slide, please. Okay, here's a little bit of information about me. I am an assistant professor at the City University of New York, so I'm located in New York City. And I also work with the PFAS Project Lab from Northeastern University, where most of this research that I'm going to present took place during my postdoc. Next slide, please. Great. So as Dr. DeWitt described, PFAS are used in a lot of different products, and we tend to think a lot about consumer products. Thinking about minimizing individual exposures is, of course, of concern. But it turns out that PFAS are in more than just consumer products, and they're used in different industrial processes before we get the products, and they are used in different applications that lend them to be emitted into the environment in mass quantities. And so I have some of the main sources of PFAS contamination listed here, and I'll briefly go through them. So PFAS are emitted from military emergency training and airports because of the use of something called aqueous fluorinated firefighting foam, or AFFF. And so this is a firefighting tool that uses PFAS's persistence and their particular chemical structure in order to fight oil and gas fires. So if you've ever worked in a kitchen, or have learned about home safety, if you have an oil fire or a grease fire, you don't want to throw water on it because it will come back and burn you, and it also won't do anything to put out the fire. And so oil fires are very difficult to put out. And what PFAS do, because they are both oil and water resistant or repellent, if you spray PFAS onto an oil and gas fire, it snuffs out the fire, it starves it of oxygen. And so that can be very useful for putting out fires that are difficult to fight. And so for a very long time, the US military and airports were required to use fluorinated firefighting foams even in emergency response drills. And so these would happen in the case of airports and military facilities, typically monthly, and it was required that those fluorinated firefighting foams be used even in drills. And so we see PFAS downstream in high concentrations from military facilities, airports, and then emergency training as well. So firefighting training centers, but also things like incidental releases. So if there's, a gas, an automobile accident involving a gas tanker or something like that, they'll spray fluorinated firefighting foams typically. There are alternatives available, and they're becoming more widely adopted. Europe was pretty quick to adopt alternatives for airports and military, where the US has been a little bit slower. And so I know that in Montana, there's been some activity around addressing the use of fluorinated firefighting foams. And so that is one of the biggest sources that we see of PFAS, at least for volume wise. We also see PFAS emitted from industrial facilities, of course, in making those consumer products and use in industrial processes. They're used as lubricants, they're used as etching agents in semiconductor manufacturing. There are many, many industrial uses for PFAS. We also see them downstream of landfills because landfills leak, and landfills take industrial waste from those upstream producers and users, as well as household waste that can contain PFAS. And so we see it downstream in leachate. We also see it downstream from wastewater treatment plants, again, because they accept industrial waste. They also accept, anything that is upstream that comes into the system. So if there's, a military base or an airport upstream, some of that contaminated water will make its way into the water treatment plant. Now, something that's interesting about a lot of PFAS chemicals is they are so persistent, and that carbon-fluorine bond is so strong that PFAS don't break down in our traditional wastewater treatment processes. And so we can see that some of those shorter-lived precursors can be transformed into other more long-lived PFAS species through the wastewater treatment process. And so we do see PFAS coming from wastewater treatment plants. There is activity in filtration and partitioning that out, but then that ends up going back into its own kind of waste stream, right? What do you do with the spent filter? There's also concern about land-applied biosolids. So that's some of that partitioning from wastewater treatment plants. So in agriculture, it's quite common to accept municipal sludge or biosolids to spread on farms. And there's been a lot of activity looking into PFAS coming from that source as well. Specifically in Maine, there's been a lot of investigation around that. We also have evidence that it's used in oil and gas development. There's an interesting series of studies from Physicians for Social Responsibility that have looked in states with fracking activity. I'm from Pennsylvania, so I'm very interested in this in particular, and found that maybe unsurprisingly, PFAS are a component of fracking fluid. So those are some of the areas that we know that PFAS come from. And so knowing what we know about where PFAS are coming from, how do they behave in the environment? Next slide, please. Great. So those chemical properties that make them so useful for these industrial applications also make them fairly persistent and hazardous in the environment. So some of the key characteristics of PFAS are that they are extremely stable, and Dr. DeWitt talked about that with the long lifespan in the environment and in our bodies. They're also mobile, and I will say that with the caveat that it really depends on their structure. Some of them adhere to things like biosolids, to more solid media, soil, and others are carried through the water and through water cycle, and it often depends on their size as well as that functional group on the end. But they have been found to travel across the world through different cycles, specifically the water cycle. And so they've been found, nowhere near a source of PFAS up in Arctic ice, for example, and in Arctic tissues. So mammal tissues, seals, whales, and other tissues as well with fish and birds. They're also very persistent, and so they can be very difficult to break down or to remove from environmental media. And as Dr. DeWitt mentioned, they're also bioaccumulative, so they can stay in our bodies for a long time. And something that is relevant to concerns about fish are that they can biomagnify as well. So fish species will have PFAS. If they have PFAS in them, they are eaten by a predator species, or people will move up the food chain, and so wildlife in particular can end up with high concentrations of PFAS. Next slide, please. So thinking about what we know about PFAS, how they're used, how they get into the environment, if our goal is to turn off the tap on PFAS and stop it from being emitted into the environment because we know about its persistence, its bioaccumulation potential, we need to know where those taps are. And so thinking about where are PFAS, this is a map that is very similar to the one that Dr. DeWitt showed, showing where PFAS has been detected in environmental media. This map does not show drinking water detections, but this was compiled by the PFAS Project Lab at Northeastern University, and this was compiled right before I joined the lab in 2022. And if we look at this map, you would say, oh, okay, so this is where PFAS have been detected. And let's pretend we have a pot of money to allocate for remediation. Where should we focus? New England, probably. California, they really have a lot of PFAS there, don't they? Good thing that, Montana or Kentucky, we don't have to worry about PFAS there, right? That's not the case at all. And as Dr. DeWitt alluded to, this merely shows PFAS testing, right? We have to test for something to know that it's there. And so that's what Montana has recently has learned public information about where PFAS have been detected. And so this map is available in an interactive version at the PFASprojectlab.com. I will put the link in the chat. And so we noticed that this was very limited, right? This doesn't tell us a lot about where PFAS is coming from necessarily. We can use the information that we have, but it's likely that PFAS is probably more widespread. Next slide, please. So in preparing for this webinar, I took a look at Montana, and this is the interactive version that you can find on the website. And we found that I found that there were 5 known sites of PFAS contamination, and now after speaking with the MEIC folks, there might be some more to add to this list, but 5 sites, and if you look at which ones they are military facilities and airports. So those are facilities that have federal testing programs. Airports don't have federal testing programs necessarily, but they tend to be like the second most commonly tested source of PFAS. So this doesn't tell us a whole lot about where PFAS is coming from. Next slide, please. So my colleagues and I developed a model to determine where PFAS might be coming from to fill in those gaps about what we know. We can't wait for every single state to test all of their environmental media for PFAS. So what can we assume in the meantime? Because people don't want to wait for that, right? If we're turning off the tap, it's running. So let's figure out where it's coming from. So using what we know about PFAS, we were able to identify several different types of sites that are highly likely to have PFAS. And there's a paper about this that I have in the references at the end, where you can read the specific methods. But we identified different categories of sites that are likely to have PFAS, and those are AFFF discharge sites, so places that were for a long time legally mandated to discharge AFFF into the environment. Industrial facilities that produce or use PFAS, and we identified 38 different industrial codes that are extremely likely to use PFAS and emit it into the environment, as well as sites related to PFAS containing waste, and so those are the landfills and wastewater treatment plants. And so we were able to collect data about where these sites are across the United States to hopefully get a more realistic picture of PFAS across the US. Next slide, please. So the result is this map. And this map has 78,000 points of presumptive PFAS contamination. For reference, that other map that I showed earlier with the big gaps has about 2,000. And so this is a more realistic landscape of PFAS contamination sources across the United States. And so you can see that there are quite a few more than what is shown in our current testing regimes. Next slide, please. And so thinking about Montana and hearing Montana's story, one of the questions that was raised to me is, where's PFAS coming from, and why did we see different results in different tissues or different fish tissues or in different areas? And I certainly can't say with 100% confidence, but I took a look at our map. So this is the presumptive contamination map. This is an interactive version of the map that I just showed in the previous slide. And when I took a look at where the samples had been taken, I saw that the higher levels in the fish tissue were downstream of military facilities. And those with lower detections were downstream of waste sites. And this was really interesting to me because in the paper that was listed on the previous slide, we looked at the contributions that these different site types are making to PFAS concentrations. Next slide, please. So this is a figure from that paper, and I will just give a brief overview. So the y-axis shows various measures of PFAS from publicly available data in that known contamination data set. So they're categorized on the x-axis by different site types. And so we can see overall that military, airports, and municipal fire activity sites consistently and significantly have higher PFAS detections than those associated with other sites. And I don't want to say there's no issue at other types of sites, because if you look at the dotted line at the bottom of each of these figures, that shows the EPA maximum contaminant level, or the proposed maximum contaminant level value for PFAS. And so these are groundwater detections. And so this suggests that all of the different site types are associated with elevated PFAS concentrations above those drinking water guidance values. We don't have groundwater guidance values, so using drinking water guidance values is a very conservative approach, but it would be a health protective approach. So this shows that all of the sites are associated with elevated PFAS concentrations. Next slide, please. And so if we think about what military facilities, firefighting operations, and airports have in common compared to the other sites, we see the use of AFFF. And we found that AFFF users, if they were categorized, and if we categorize that data set into AFFF users compared to other site types, AFFF users consistently had significantly elevated PFAS concentration in groundwater. And so this shows that likely the use of AFFF is leading to elevated PFAS detections, and that is in keeping with what was observed in Montana. And so, while I can't say absolutely for certain, it is interesting to see that the higher detections were found in fish tissue downstream from military and airports. Next slide, please. Okay. So these maps are available. They're interactive. You can search, your house and see what's around. We also share this data. If you send me an email, I can connect you with someone at the PFAS Project Lab who shares all of our data and manages that. Both the known and presumptive contamination data sets are accessible. We're happy to share them. And so you can look at all of these different sites of where PFAS are likely coming from, and you can read the papers that we wrote about them if you are into reading peer-reviewed research. Next slide, please. So thinking about where PFAS comes from not only has implications for policy, for homeowners and residents dealing with PFAS contamination. It also has environmental justice implications, and something that stands out to me in particular about the case in Montana is that there were detections in fish tissue that were right outside of tribal lands. And so I want to highlight the environmental justice implications of fish advisories. I do some work with the Tribal PFAS Working Group, whose information I can also put in the chat. And something that I've learned through working with them is the importance of promoting and maintaining traditional lifeways, and fish consumption is important to many, many tribal groups around the United States. And so fish consumption and fish advisories are something that the Tribal PFAS Working Group thinks a lot about and talks a lot about. And so if people have concerns about fish consumption, I'm very happy to connect you with those folks But this demonstrates just the interconnectedness of all of the issues around PFAS. And this is a kind of complicated Venn diagram that I created for a paper that I wrote, connecting the scientific components with the corporate responsibility components, governance and policy, along with the community input and the community impacts. And so all of this working together towards the goal of turning off the tap and getting a drastic reduction of PFAS use and exposure. So thanks so much. And I am happy to take questions. I see there's one in the chat, but I'll take questions at the end. Thanks.
Thank you so much, Dr. Garrett. That was really illuminating, and it really just goes to show that we can't say there's not a problem if we haven't looked for it. And that's unfortunately, I think, been Montana's stance for a while. And that's what this really important reporting on the fish tissue has shown, that, we're experiencing contamination as well, just like a lot of the other states that have gone to look for it. Our next speaker is Avonna Stark. Thank you so much for being here, Avonna. Avonna became the Minnesota State Director of Clean Water Action Minnesota in November 2022, having worked in politics for almost 2 decades. Avonna received her bachelor's degree in political science and history from the University of Minnesota Twin Cities and her master's degree in political management and advocacy from the George Washington University in Washington, D.C. With Avonna's leadership, Minnesota became the first state to pass the most comprehensive PFAS bans in the world, known as Amara's Law. Her work to bring industries, agencies, lawmakers, and advocates together has set an example for states across the country to pass similar legislation. As an advocate, Avonna strives to raise the voices of those who are typically left out of the political processes. So Avonna will give us some ideas of what we can do. Thanks very much, Avonna.
Thank you. We can go ahead to the first slide. We'll jump right in and talk about what turning the tap off really means in the literal. So Amara's Law is named after a young woman who lived in a contaminated area of Minnesota, close to 3M, where 3M dumped quite a bit of their PFAS in the 1970s. She sadly passed away a few days before the first vote on this bill and just a few days before her 21st birthday. So as this law was being finalized, it was very kindly named in her memory. And Minnesota is, like you said, the most common ban on PFAS in the world, but I really do hope that we are unseated. I hope that other states are able to take that away from us, and anything that we can do to help, we are more than willing to do. So the first portion of Amara's Law is a ban on the sale of these 11 consumer products that contain intentionally added PFAS. I won't read the list, you can see it there, but what ended up happening was we started with quite a small list, and then we kept having manufacturers reach out and say, hey, can we be exempted from this? And our response was, well, we didn't know that PFAS was in that, and that's really disturbing. So we're going to add you to the list. Dental floss was one of those things. So any sort of dental floss that says smooth glide. So a previous speaker talked about kind of the waterproof, oil-proof, grease-proof components. You can really see on that list how those might be expressed. Things like waterproof mascara, for example. And I do want to highlight that, we had a lot of lobbyists coming into Minnesota and threatening that we were going to have empty shelves. There weren't going to be products to buy. We have not had that problem. If anything, we have had the exact opposite. Stores are really finding that it is profitable and beneficial to sell PFAS free and to advertise that products are PFAS free. We're seeing the market move more and more away from using these toxic chemicals as community education rises and people are more aware. Starting in January of 2032, the sale of, and that should be January 1, I must have had fat fingers, I'm sorry. The sale of any product with intentionally added PFAS that is not listed above will be considered unable to sell. Now, the caveat is we have an essential use only provision in Minnesota. So, for example, there are components in MRI machines, certain things in airplanes, that pacemakers, if the product is essential for the health, safety, functioning of society, and there is no safer alternative, they can apply for what is called an essential use exemption for a period of time. So that is really important to note. We did have a lot of folks worried that, Minnesota wouldn't have MRI machines or some of these really critically important items that serve the health, safety, and functioning of society, and that's just not true. We do have a requirement that businesses and manufacturers are disclosing if they're selling products that contain intentionally added PFAS. That information gets reported to the Minnesota Pollution Control Agency. They have been a wonderful partner in this. I cannot praise them enough, and I really do encourage agency officials to reach out to the MPCA. They are wonderful collaborators. We have a pathway to ban all forms of PFAS and firefighting foam. I actually just had lunch with a government relations person from an airline, and they're actually working on a way to go completely foam free, period, because jet fuel is very different than typical fuels. There are out in Washington, Delta has gone to complete water, only water, no foam, and they're on track to do that in Minnesota as well. So that's really exciting that that is an unintended consequence of this legislation. We also have passed legislation related to PFAS outside of Amara's law, and a really good example of that is that we do ban PFAS in food containers. So think of pizza boxes, Chinese food, anything that is meant to contain liquid, grease, or oil. You cannot use PFAS now in Minnesota. Next slide. So states really do have the power to make change, and it's important to note that the majority of our landfills in Minnesota are leaching into the groundwater. So turning off the tap of selling less of these consumer products is really important, because at the end of the day, all of these products end up in a landfill in one way or another, which means everything in that landfill is leaching into the groundwater. So states have to really take personal responsibility for themselves, I guess, for lack of a better term. And we have the power to do that. There are over 30 states that have adopted 193 policies, and 33 states have introduced 191 policies related to PFAS and turning off the tap. If you go to saferstates.org, they have a really wonderful interactive map that helps you see what your particular state might be working on, and then getting ideas on what other communities are doing, because every state is a little bit different. There are forums like this, panels, conferences across the country. My favorite is the National PFAS Conference that happens every 2 years, and that is a really great space for scientists, elected officials, advocates, impacted community members to come together and share what they've learned and what they're working on in their life experience. The most recent National PFAS Conference featured a doctor who was making headway in using a cholesterol medication to help offload PFAS from the human body. So we know that PFAS is a forever chemical. We know that it doesn't break down, but we do know that giving birth, menstruating, lactation, giving blood, giving plasma can help reduce your PFAS load in your body. And so there's a lot of studies around what can we do to help people who live in these impacted communities so that they're not living with this forever consequence. I have been fortunate enough to bop around to multiple different states across the country where their legislators are having informational hearings. PFAS is a tough topic. There's a lot to understand. And so there are a lot of decision makers that are truly working really, really hard to understand what's happening at the state level. And it's even more important that we're working at the state level, because at the federal level, we're not seeing a lot of consistency. The photo there with the woman in the hat is the former chair of the White House Council on Environmental Quality, Brenda Mallory. She came to Minnesota, and we were so grateful that the Minnesota Pollution Control Agency gave her a tour of the SAF, which is a machine that to keep it short, essentially removes PFAS from water, is the very short and dirty of it. And the Biden administration was working really hard to understand the problem, come up with solutions solutions. They had reached out to Amara in her final days of life and wanted her to address the White House, which she was unfortunately unable to do before she passed away. And the next image is a headline that we are seeing rollbacks on limits on forever chemicals under the current administration. So what we see, what we saw with the Biden administration was a real embrace of the addressing PFAS as a class of chemicals. There are tens of thousands of PFAS chemicals, and it's very, very important that we address them as a class and we don't pick and choose, where what we're really seeing now is one set of limits on PFOA, one set of limits on this other PFAS. And once we start to pick and choose, we get into a really, really dangerous game, because while we haven't tested every single PFAS in existence, those that have been tested all showed detrimental impacts onto human health. Next slide, please. So the lessons that Montana can take is that you do have the power to lead, and states have the power to support each other. Please lean on states that are taking proactive measures. Reach out to our advocates, reach out to our legislators, reach out to our agencies. We want to help. You know, water doesn't respect political boundaries. What's happening in Minnesota impacts Iowa, impacts Wisconsin. We're not existing in a vacuum. And reach out to the source. So we're seeing a lot of pro PFAS groups bopping around saying that Amara's law in Minnesota is failing, and I cannot say this loud enough. That is not true. This is a successful law that is doing really good things. And so if you have anyone who's coming into Montana, please reach out to me, reach out to our legislators, reach out to our agency, anything that we can do to help. This is a nonpartisan issue. Contaminated water doesn't care how you vote. It doesn't care how old you are, where you grew up. And contaminated water certainly didn't care about any of those things with Amara when she became ill. And so it's really important that we're having these conversations across party lines. We are reaching out to our neighbors and we're working on this together. And residents have the power to make change. So you can change your shopping habits. You can, read that label. Anything that claims to be nonstick or waterproof, ask those questions. What makes it nonstick? What makes it waterproof? Reach out to businesses and let them know that you want them to make change. I've bought your product for 20 years, but I'm concerned. Please do something about this. Talk to your neighbors if you see them using pesticides or other toxic chemicals on their yard, or, if you go over for dinner and they're using a bunch of Teflon pans. If you have a private well, test your private well, and work with your elected officials at every level of government, your city council, your state legislature. I'm a school board member, so if you have artificial turf on your athletic fields, there's a strong possibility that there could be PFAS in that artificial turf. So as you see those line item budgets coming through for approval at every level, ask, what sort of product is this? Is this safe for my children? I will put my contact information into the chat. I know we're running short on time, so I'm trying to go fast, but please feel free to reach out and I can connect you with anyone who might have any ability to help you in Minnesota for whatever your Montana goals might be.
Thank you so much, Avonna. And yes, just to point out, we're about 5 minutes from 1 o'clock, but we'll talk about these public opportunities for engagement, ways to use your voice. And then if folks still have time and want to stick around, we're really happy to take questions and to continue this discussion. So most importantly, or most urgently, I should say, we have a meeting on July 14th at 1 p.m. On the agenda is a hearing on PFAS and fish tissue, and we will have all of these important directors of state agencies available during that to hear from the public and to hear how concerned we are about this and that we want action. And of course, the legislators on that committee as well should hear that. The way to get registered is to go to ledge.mt.gov. I'll send you all this information. You click a public participation button. The really important thing is that you have to be registered at least 2 hours prior to the meeting in order to give comment. You can also send a written comment the day before, and they will have it printed and delivered to the council members on their desk as they begin the meeting. So we'll send that information in the follow-up email. If you please share your email in the chat. Also super important and mentioned in Avonna's, that headline she shared there. Our current federal administration, the EPA, is proposing to roll back some important rules that protect us from PFAS. And this is just a free pass for corporations to continue to pollute, and we pay the price both with our health and with taxpayer dollars to remediate this down the line. And so there are two, of course, they're not making this very easy. You have to comment on these two different proposed rules in two different places. But there's the docket numbers. Again, we'll send you all of this information to make it very simple. We have an action alert set up at MEIC's website as well. But we want to see these protections actually implemented, not delayed and not removed. So we need to let the EPA know that this is really important to us. This is the second one, which is a rescission of 4 different, oh, sorry, that was the first one. A rescission of any sort of monitoring of those 4 chemicals. And this is a rollback of extension before we enforce this really important maximum contamination level. So again, please share your email and we will follow up with all of that information and make it very easy to participate and share your voice and ask for change with this. So want to share or save a little bit of our time for question and answer here. So take a look in the chat and see, it looks like there's been some action in here and some things answered. Let's take a look.
Yeah, Ben, I did take the liberty of answering one question. Just, it was more of a point of clarification.
Gotcha. Thank you very much.
I'm
Okay, I
happy
see. Go ahead, Dr.
I'm
Garrett.
happy to answer Howard's question. Howard, he asked in the chat, for those that can't see, is there's a graph in some of my recent work showing that dry cleaning sites are the second highest source of PFAS behind metal coating facilities. Is this happening at all or most dry cleaning businesses? First of all, I am absolutely tickled that you are in the supporting information section of a paper. That is assume that no one will ever read that. So thank you so much. The second is that the second point, and the answer to your question is that figure that shows that dry cleaning facilities, they have about like less than half in terms of counts compared to metal manufacturing is from the known contamination data set. So it doesn't necessarily show, things like concentrations or how many there actually are. It is how many have been tested. So we know in terms of the specific industries, so we have industry as a kind of broad category, there are 38 different industrial sites that we can presume are sources of PFAS contamination due to documentation of their activities. And dry cleaning facilities are not necessarily the second most numerous throughout the country, but from what we know about testing in groundwater, they are the second most numerous behind metal manufacturing. We see that they don't necessarily make up a huge proportion of the most likely sources. So if you scroll down in that document, there's another figure that shows that metal coating and manufacturing, again, is the most numerous across the country, but the second and third places are a little bit different.
Thank you. Is PFAS volatilized by dry cleaning? Does it go directly into the air?
I don't know. I don't know enough specifically about the PFAS that they use. That is really interesting. And air exposures to PFAS is an area of more recent study and concern. So that's a great question that I don't have the answer to. But I have one more caveat on this point. So if you are snooping around in the supporting information, which great again, there are several figures showing those sub-industry categories with concentrations. We did not have enough data to make substantive connections between particular industry categories and concentrations. So look at those figures with a grain of salt.
Thanks. I expected it was partly due to the amount of testing, but thank you.
Yeah, those figures come from the known data set, which is inherently limited.
Thank you very much, Dr. Garrett. Thanks for the question, Howard. The next one I see here and here is from Augustin, and it says, what can be done when watersheds cross state lines? We can enact change in our state, but when actions of neighbors affect us and when we are not allowed to change their state laws, is this cause for a more federal push? I'd like to pass this one to Avonna, but also just say that, Montana's a headwater state. And so most of our watersheds originate within our boundaries. And so, we might be seeing other states looking at us and saying, hey, we're going to take action against you if you don't do something about this because we're receiving all of your downstream pollution. But we'd love to hear, Avonna, you kind of mentioned that with Minnesota, Wisconsin, Iowa, and you're kind of a headwaters state there as well.
Yeah, there are multiple groups that state legislators in particular are members of. Examples are the Mississippi River Legislative Caucus. There is another group called the National Council of Environmental Legislators, and these are all groups of legislators that come together, left, right, and center to focus on issues related to the environment, the Mississippi River, water, that sort of thing. So I would reach out to your specific state legislators and ask them what coalitions and organizations are they a part of. What kind of conversations are they having? What are they hearing? There's also, for us border states, we can't forget that we have a northern neighbor as well, and explore that relationship with Canada, and the work that they're doing and the work that we're doing. Minnesota in particular, we share Lake Superior with our Canadian neighbors. So there are various multiple ways that legislators can work together. And then there are organizations like Clean Water Action, but we have offices across the country. So we're able to coordinate our offices, but also our legislators in that way. And then Safer States works across the country. They organize environmental organizations like NRDC, Clean Water Action, and the like to do this sort of work. So if there is a specific interest there, please shoot me an email and I'll see what I can hook you up with.
Thank you very much, Avonna. The last question I see is from Peter Dudley, and I know how to follow up with Peter. I'm getting bumped because MEIC, we share our Zoom, and we have another use for it right now at 1 o'clock. And so I just want to say thank you so much to our panelists and for giving us your expertise and your time. And if you have other questions, they have shared their contact information. We will send a follow-up and would love to continue the discussion. And of course, there's going to be lots of opportunity to comment on this in the coming weeks. And then also want to say that in the legislative session in January 2027, it's going to be really important that folks let legislators know that we want action on this. We did have a bill somewhat similar to Amara's law last session, and it did not get any traction, but we also didn't realize, legislators were able to say, well, it seems that there's not a lot of identified contamination of PFAS in our state. And as we saw, that doesn't mean that it's not there. And we've now found out that it is widespread across our state. Thank you so much, everyone, for being here again.